Okay, let's continue on working solving these problems on on the inheritance of cystic fibrosis. Suppose that individual 9 has 3 children and none are affected. What is the probability that the next child will be affected? All right. So number 9, we do not know the genotype of number 9. It could be big A, or big A, little a. So we just put dash here, this unknown genotype. She married a known carrier, and they have 3 children. None of them are affected. So let U3 equals first 3 unaffected children. What is the probability of number 9 being carrier? 2/3. We already established that fact. What is the probability of number 9 being non-carrier? It's 1/3. Well, let me repeat this thing again. Number 9, why do we have 2/3 and 1/3? So number 9, individual number 9 had parents number 3 and number 4 in the pedigree shown before, not on this video, but both parents were carrier. Okay, so if both parents are carrier, then then 1/4 individual will be affected. Okay, and 3/4 individual will be unaffected. That means they do not have disorder. Okay, 3/4, 1, 2, and 3 out of 4 individuals are unaffected. So out of 3/4 unaffected, 3/4 unaffected, we have 2/3 are carriers. Okay, 2/3 are, this is 2/3, and they are carriers because they carry bad alleles. And 1/3 out of 2/3 unaffected, out of 3/4 unaffected, 2/3 are carriers, and 1/3 is non-carrier. So now, what is the probability of having 3 unaffected children given number 9 is carrier? That comes 3/4. That comes from this Punnett square. Whenever both parents are carriers, the probability of them producing unaffected kids is 3/4. And if 3 children are unaffected, that means 3/4 to the power 3. What if number 9 is non-carrier? What is the probability that she produced 3 unaffected children? It is 1, because number 9 is unaffected, she is non-carrier. That means she has big A, and she has big A. When she has babies with a known carrier, all the kids will be unaffected, although half of them will be carrier. So 1 probability of unaffected children if she is non-carrier is 1. So what do we want next? We want what is the probability next child affected given the fact that she has already 3 unaffected children. So for that, we need to produce the probability of what is the probability that number 9 is carrier given she has 3 unaffected children. First 3 children were affected. To calculate that, we have to use the Bayes theorem again, which is probability of carrier given 3 unaffected children equals, what is the probability of carrier? What is the probability of producing 3 unaffected children given cis carrier divided by overall probability of producing 3 unaffected children, whether she is a carrier or non-carrier. So that's why this denominator is equivalent to numerator, which produces denominator is equivalent to probability of carrier and still producing unaffected children times plus probability of non-carrier, number 9 being non-carrier, times what is the probability of producing 3 children given the fact that probability of producing 3 unaffected children given the fact that she is non-carrier. So we need to solve this equation here. Let's plug in the values here. Probability carrier is 3/4, 2/3. Producing unaffected child is 3/4, and for 3 children consecutively, power to the 3, and denominator also has these terms. We repeat the same thing here, plus being non-carrier 1/3 times producing 3 children given unaffected children given C is non-carrier is 1, and the probability comes down to 27/59. This is the posterior probability. Now, after we did calculation that C has 3 unaffected children, this is the probability that number 9 is carrier. Now, what is the probability of next child is affected? For that, we have to simply multiply what is the probability of producing a child who is affected is 1/4, and what is the probability of number 9 being carrier is 27/59, and you simply multiply, which will give you the percentage 11%. Now let's move on to the next problem, which is slightly different. The question is, suppose the individual 9 marries someone from the general population, where the frequency of disease incidence is 1/25. Then what is the probability that a couple produces an affected child? So we know number 9 being carrier is 2/3. The second parent being carrier is 1/25. What is the percentage? What is the probability of that child being affected? Is, let's do the Punnett square, right? So let's assume both are carriers, and then if both are carriers, the probability is 1/4. 1/4 being an affected child, but we don't know if they are carrier. So the first parent being carrier is 2/3, second parent being carrier is 1/25, and they producing affected child is 1/4. You simply multiply these probabilities and it comes down to 150. Okay.